Hello everyone, welcome to my Physics 101 final project presentation. My name is Metin Berk Porazan and I am a second year mathematics student at Bilkent University. My experiment is titled Determining the Coefficient of Static and Kinetic Friction Using an Inclined Plane. My primary goal was twofold. First, to accurately measure the static coefficient of friction and the kinetic coefficient of friction for a wood-wood surface pair. My second goal was to investigate whether these coefficients are truly independent of the block's mass as predicted by classical physics. My setup was simple but effective. I used a flat board mounted on a hinge, which allowed me to gradually increase the angle. I used a wooden block and a smartphone inclinometer to measure the two critical angles needed for my calculations. Now, let's look at the physics of the inclined plane using this force diagram. The block's total weight, F sub g or m times g, is decomposed into two components. The component pressing the block into the ramp is the normal force, N, which is equal to mg cos theta. The component pulling the block down the ramp is mg sin theta. Friction F always balances the downslope force. By equating these forces at the threshold of motion and during steady sliding, I found that the block's mass cancels out completely from the equation. This is the core theoretical reason why the coefficient of friction should be independent of mass. When I set the force equal to 0, the formula simplifies elegantly. This leads to my final simplified working formulas. The static coefficient is determined directly by the tangent of the static slip angle, mu sub s equals tangent of the theta sub s. The kinetic coefficient is determined by the tangent of the steady slide angle, mu sub k equals tangent of theta sub k. The experiment successfully yielded the expected results and provided an interesting deviation. First, I confirmed the core principle the static coefficient was greater than the kinetic coefficient. Second, regarding the effect of mass, my data revealed a slight yet consistent increase in both coefficients as the total mass was increased from 150 grams to 350 grams. As you can see on the graph, the lines trend upward. This small deviation challenged the idealized theory. I conclude that under real experimental conditions, the heavier block slightly altered the contact interface, likely by causing minor surface deformation, which increased the friction to normal force ratio. In summary, my experiment successfully validated the core physics principles of friction using the inclined plane method. I confirmed that, while the fundamental relationship holds true, friction coefficients primarily depend only on the surface and not the mass. My practical results highlighted that real-world factors like slight surface deformation can cause small, measurable deviations from the simple theoretical model. This project provided me with valuable experiments in data analysis, error propagation, and reconciling ideal theory with experimental reality. Thank you for your time.